starts going, wait a minute, there's some misconceptions of engineering practices. We thought it might be useful to describe what real engineering goes about, or not real, but engineering in companies. And what you guys are doing is somewhat related, but I'll show you some of the differences. So one of the things is you'll discover there's a lot of processes that people talk about. People have a lot of assumptions of what a process is that you go through, and it turns out that you can make up your own process. It doesn't matter. People have a lot of ones that work, and then they keep using them. And that's basically how a lot of this has evolved. People have just sort of discovered these things work, and they continue with it. However, you can always find cases where people will say, oh, no, that doesn't work, and they'll give a story. Or they'll have their process that is better than yours, they think, and they'll give success stories. So there's plenty of successes. So the result of that I figured out is most of the time things succeed because people want them to succeed. You're making a product, you want your product to be successful, so you'll work with any process that is there. Even if it's a bad process by someone else's measure, you're going to complete your project. I mean, that's your primary goal. So most of it is just sort of like, do you want to spend your time trying to feed a bad process, or do you want to spend your time making a great product? And so processes are really just a tool. And hopefully you can pick one that uses the least amount of overhead in your time. So basically, since a lot of this is opinion, I thought I'd describe, okay, this is my background, where I came from. I worked 12 years at HP, or 18 years, and then I've spent 12 years doing startups. At HP, I started back in 1981 and was part of a team that did the first PC for HP. It was just after the IBM PC was released, and HP wanted a competing product, and so this was a system that was a touch screen. It was one of the first ones where you could point your finger at the screen and have it work. It was actually implemented quite simply with LED arrays and photosensors in a grid. So it was nothing like the cell phones and stuff we have today. So it's very crude in its approach, but you could touch and draw things on it and select menu options and so forth. So it was pretty neat. And I guess my biggest accomplishment there was I actually had software that got on the cover of Byte magazine, and that was kind of cool. And then in year 2000, I started working with startups. I had a friend who moved to a startup, and he invited me to join. And so I've been, like it shows there, I've been with 5. Let's see, of the 5, all have failed except one. So it's the one I'm currently at now. I've been with it for about 6 years. So it's beyond a startup now. It's now, you would call it a small business. So right now I deal with release operations. I'm sort of at the end phase of products. When I was at HP, I worked in the R&D labs, and so I was at the beginning phase of projects, so actually creating the project and coding it up and so on. And now I'm more at the end phase of getting things production ready and getting them into production. And I'm actually in charge of a lot of servers. In my operations role, I'm on call 24/7 to keep the website up. Right now, I'm basically their only system admin. We have another admin for a contractor to help with networking, but that's mainly my main role. Jumping right into it, there's sort of 2 parts that I looked at. One is sort of what goes into the engineering process. What kind of things do you look at? How do you evaluate whether something is good or bad? Is it meeting your goals and things like that? And then there's the lifecycle part of which I'll get into next. This is an acronym that HP came up with, FLURPS, to basically just be able to remember, and I remember now years later, the acronym, of what kind of things go into a product. And when you're doing your specifications, your external specs, internal specs, all of that, they basically want you to address these main areas of focus and have some comment about it. How are you going to approach this? How are you going to implement it? And things like that. So functional, well, sort of like, does it work? It's basically what the functional is going to be about. And it's sort of like in your case of making a robot, it's making sure it meets the goals. Localizable, it's more than just languages. It turns out there's things like in Europe, they do day, month, year. We have month, day, year. Also, they use comma for their decimal point and periods for their comma separator. So things are all flipped around at times. So you have to, when you're writing software, you have to be able to make sure that if you're working with a worldwide company like HP, that software can be localized, put into the formats that's needed. And that's not a fun task. I actually have worked on software that implements that, and it's mind-numbing, the details you got to go into. Usable. Particularly, that's sort of related to quality. But I came across something that was kind of interesting. One of the consultants I've read said, quality really, it doesn't mean zero defects, or it doesn't mean bug-free. You could have a completely bug-free piece of software that no one really likes. Never crashes, but no one wants to use it. So that's not a very good quality product. So quality is something really that people want to use. Apple products I've seen, great products, they're really cool, but I talk to Apple people and find out they crash all the time. Well, not as much as Windows, but, they do die. But people like it so much, they're willing to put up with it. And so that's a good, usable product, and that's what's good about Apple. They focus on quality from that perspective. Reliability, basically, that's a little bit related to usability. If something crashes so much that you're losing your data, you're really not going to like it. So reliability is sort of about that, of making sure that it stays running and doesn't mess up stuff. Performance is usually it's something that you do towards the end of a product phase. You try to make it perform better if there's problems, if users are waiting for something, you want to improve the performance. But usually you only do that towards the end. One problem I've seen is sometimes people will try to do performance improvements before they even have it working. It'll be too slow if we do it this way. Well, wait a minute. What do you mean this way? It's not even running yet. So you got to get something going to determine, is the performance really going to be bad? Because maybe it's good enough. No one will care. You saved yourself a lot of time, maybe, not optimizing something that didn't need it. Supportable. This is more for manufacturing type things, where you've got customers you're going to support, and that's what that's mainly about. And one thing I've discovered is the current computer industry, sometimes they often will say, oh, gee, you're on an old version, upgrade, and then we'll talk to you. Well, from my perspective as an end release engineer, where you track things, you're supposed to have a copy of every version that a customer would have, so you can reproduce the problem, because maybe it's too expensive for them to upgrade. Maybe they're going to introduce new problems they don't know about. So you've really failed in the supportability thing if you're telling your customers to upgrade. Is sort of the way I think about it. Next thing. So life cycles, there are two main styles. There's the waterfall and then the agile. There's others you could probably say. But waterfall was sort of some of the original life cycles that most people are familiar with. And I would go over it first because, in fact, with the Agile life cycles, they have elements of the waterfall in them. They just tighten it up. Instead of a waterfall being for each phase for the full project, you iterate across multiple phases. And so what are those phases? Now I've got to... So the idea phase is sort of at the very beginning, of course, and these things don't really occur in that order. They may be in any order, they may be shuffled around. Primarily, you exit the idea phase when you've got an accepted proposal. You're saying, this is a project, give us some money. Let us go with the rest of this. Because they're going to commit, a company's going to commit to a lot of time. So that's your main goal for your prototype, is to show things to get them to accept your proposal. Design phase, okay, you've got a project going, and so you start with your project plan, which project plans are basically, it's sort of like scheduling, but it's more than that. It's also where you're doing your task breakdown. You're trying to figure out what are the different parts of this project, how do we fit everything together, and what are the dependencies on things, which things need to be done first, which ones last, who are we going to be waiting on. Things especially important are like external dependencies. I depend on another company for some service or some product or parts. What is the lead time? And do we have it in the schedule such that it's going to arrive in time? Things like that. External design is basically the design from the perspective of a customer. What is the customer dealing with? What are they having to interface with? What are the buttons they're going to push? Things like that. That's external design. And you basically want to approach it from a usability type of perspective of making it so that you have something people want to use. Internal design. Basically all the stuff under the hood that makes it work. And mostly what you're concerned with there is having decent performance. You don't want to write it so that it's going to be completely horrible. You know, if you're dealing with software, you don't want to do a bubble sort for anything. You know, it's real fun to talk about, but beyond 10 items, most computer science people know that's a crappy sorting algorithm. So you're going to pick ones that you know have been proven to work pretty decently and have libraries that you can use. And so that's internal design, is deciding on how are you going to organize all these pieces and get them so that they can satisfy the external design. Let's see, implementation. Okay, then you get into the guts of it. Where you start coding up some things, and you create your modules and get them all set. Everyone builds this. Now this is a waterfall. Everything's done all at once. You create everything, and then you slam it all together in your development integration and hope it works. Well, actually, what you do is that's a phase that usually doesn't work. You then have to go and rework your modules, get everything working. Well, the thing is, then you got the next level of system integration. Your product usually doesn't live a little island of its own. It has to work with other programs or other systems. So now you try it there, and you discover things don't work there either. So you rework and rework till you get it going. Finally, you get into alpha test. And the current industry is a little bit mixed up these days. What they're doing today I would call alpha test. Because you do use real customers in an alpha test phase, but what you're really doing is you're trying to check out how well did you meet all those FLURPS requirements. Do they want to use it, and so on. And is the product functional enough? And so that's an alpha test. The beta test is more for your organization, your company. Of saying this is now a product. It's going to be manufactured. Salespeople, you get to sell it. Marketing people, you try to get people to buy more. The support side of the company, they come up and they start taking calls from customers, and so you have a limited release of things. And that's a beta test, a true beta test. It's now, what happens in the industry now, especially with websites, they merge the two, and they just get their first version of stuff and they slap it out there. And they call that a beta test, and they skip the alpha test phase, basically, sort of like, well, gee, if the good customers come, then it's good. If they don't, I guess we had a crappy product. Well, they probably could have discovered that if they had a true alpha test. But it does save a little money. So, production maintenance, basically, once you're done with that, you're done with the project, the engineering group goes away and creates a new project. Meanwhile, there's a whole production side of a company that handles the problems that are going on day to day. And then at times, they'll have defects they'll throw back to the main engineering group. Or maybe there's enhancements that people are clamoring for, and you want the product to have a long life. So in this mode, basically that's going to spawn off new projects, which you start back up here, and you do it all over again. So that's what the maintenance phase is. And you keep doing it until finally, well, you got another product that no one is buying this, so let's end it. Unfortunately, you've typically got customers that want to keep using it. So you got to give them a little notice and figure out what do you do with them. How are you going to keep them happy so they don't hate your company? So that's what the end of life phase is how are we going to retire this product? Okay, so this is an example of an Agile Lifecycle called extreme programming. There's others called Scrum. There's one, but anyway, there's a number of different types of life cycles. The extreme programming this is just a diagram of the iteration that they go through. And what they've got is elements of the waterfall in it. The requirements is like the specifications, the internal and external specifications that are going on. You have your actual planning that goes on. The iteration is where the actual coding occurs. You go through a test cycle and so on. So they're just showing the process. And the idea is that in a extreme programming phase, the cycles look something like this, where when you start out with your release plan of several months maybe involved, you create your iteration, they say weeks. I actually worked with a company where we did a release once a week. And as you go through these processes, you see you get right down into the programming. You're just only doing seconds between the changes you're making. You're doing your unit tests between minutes, and you got some pair negotiation. That's another concept that's used in extreme programming. Is you don't write any code by yourself. You write with two people, one keyboard. And the idea is that you might even have one person that's more experienced than another, so you're getting some knowledge transfer. Even if you're of the same skill set, you still get knowledge transfer. You both were part of the design of how you're actually organizing your code and how you're writing it. And most people will say, oh, gee, you're now cut your resource load in half. Well, yes, only for the coding side. What you've done, though, is you've improved the quality of the code such that you don't have to go back and fix it later. Your defects for your code go way, way down. When we were doing weekly releases, I was the main release engineer there. It was one defect that we would have. Two was astonishing, and usually we went out with zero. I mean, when it was ready to go, they'd say, oh, it's ready. We do the QA cycle of about 3 or 4 hours, and then nothing was found, push it to production. And that's the other difference between a waterfall and an iterative approach. At each one of these releases, right about here is where you would actually send it out to end customers. So you will do a very quick releases, and what you have is a complete product, as complete as you can make it, and you push it out. Whereas a waterfall lifecycle said, no, it's not really done. We want the whole thing. And so you wait till the whole thing is done and then push it out. And that may be months or even years for some products. So getting to what you guys are doing, I was thinking of how would you apply FLURPS to making a robot for a competition? Functional, you got pretty much got to meet your competition goals, and that's your primary focus. Localizable? Nah, I don't think you need to worry about that. Usable? Well, I was trying to think about that. It was sort of like, well, you want it usable enough that others in your club can figure out how to run the thing. I mean, what if, some piece of it, someone knows really well, but they're not around? Hopefully it's usable enough that someone else can figure out how to run things. Reliable? Yeah, it's not a whole lot. You're building basically a prototype, a one-off type of thing. So it's going to break down, and it's going to have problems meeting certain goals of the competition. So you want it reliable enough that it's still functional. So you want to look for what are the problem areas that are likely to happen. And that gets into sort of like risk analysis, trying to figure out, this sensor might die. What happens? And then you get into mitigations. If this sensor dies, what are you going to do? Can the software recover from that? Can it, instead of having 5 sensors, it's down to 4? Can the software adjust for that and handle when things are going forward? Maybe it just can't. You're dealing with expenses too. Performance, again, only enough to meet these requirements because maybe there's a time limit for some competition. You could solve the problem with a robot that does its navigation calculations and it takes it a full day to navigate the course. Oops. So you're going to have time limits. And so the performance is going to be part of that. Supportable, that's sort of like, can other club members fix it? It's somewhat related to usable. Just sort of like, is there enough knowledge around that this thing you're creating can be supported? This is the last one I'm going to cover before I go to questions. Sort of applying the life cycle. I sort of made this up. That's what you guys can do, is sort of make up your life cycle. Leverage from what you see on the iteration life cycles, the Agile or the Waterfall, and then pick and choose the pieces. So I would say an iterative approach is good. Sort of you brainstorm your overall approach, break the product up into modules, and then within this you would repeat your brainstorming, pick out the things that are likely that you want to prototype them as far as you can until you see that they succeed or not, and then can you assemble it with other pieces? So that's leveraging from the Agile side, is how much of this robot can you get assembled and have it work? And sort of have it work enough so that you can continue doing things. For example, if you have like a need to have this robot move, build the chassis. Once you have the chassis moving, okay, now the software for navigation can start being used. It can start moving the chassis around. As it starts moving around, the software discovers, well, of course, you need to know where you're at. How about some sensors? So you got a little bit of a feedback loop of using the hardware and software and merging them together. The next step is then part of the bigger iteration is you've assembled all the pieces, you have it now. Now what next? You sort of go back to the beginning again and say, okay, well, how does our overall project fit now? What is our next iteration? What is the next thing we want to accomplish in this process? And the whole thing to remember too in this is always have a working prototype. I once, if you're iterating on, you want to sort of keep one running robot or something around. So your software group, let's say, can continue using it. Or maybe you have to demo it. One other thing about demos is it helps keep people excited about what you're doing. New people come in, they can see something, you can actually show it. In the case of a company, it keeps your manager happy. I worked with a project team where I try to always keep a copy that's running, even if it's not the latest version. I always have a copy that's sitting around, ready to run, so I can show it. Because invariably, you're going to be asked to demo it at a drop of a hat. You don't get to pick when you demo things most of the time in companies. It's when your manager has time. And if you then are showing the latest and greatest, well, the latest and greatest is usually broken. So now your manager wanders away mumbling, going, oh my God, we're in trouble. When in fact, you're not. So I had this one project team next to me. They were in that mode. They could never demo their stuff. They would assemble it. They do their integration, their dev integration. It works at that point. Then they start tweaking it. Now it's broken. So they were constantly in a mostly broken state. And the manager thought they were out of control. So he put me in charge of the group. I said, thank you. Now my project's going to be behind. But it was mostly just teaching them how to keep a little copy aside that's running. And that keeps the manager happy. It keeps everyone excited about the project. So I'd say try to apply that to your prototypes too. Always have something that is running that you can build from for the next iteration. You may not have the resources to keep multiple ones running. You've got to eventually have to scavenge from prototypes. So that was basically all I had. I didn't want to spend a lot of time. So, any other questions, or I got more slides I could go through too if you're interested in those topics. What did I have? The baby duck syndrome. It's always cute. A lot of people imprint on the first design they have or the first piece of code they write, and then everyone does it. I do it myself, and so you just got to continually force yourself to be willing to let go of certain things. You don't want to be too quick to let go of some things because it may be worth struggling to get something to work. But you have to be willing to reorganize things so that things work. What's up?
So how about how to prototype different sections of the robot or parts of the robot at the same time? So what would be good ways to break that down?
Well, let's see. I would say for your group, the first, you have to look at sort of the divisions of what are the pieces. You obviously have a hardware component and software, so that's your first major split that needs to be addressed. And even though they're quite separate, they both work well together. And so when you prototype, you really want to get your software into the mix as soon as you can, because you'll be able to leverage things. You'll be able to, with software, make it so that the hardware is easier. You can sometimes do with software with less hardware than. But then you're now increasing the amount of time to do software. So there's a trade-off. So if while doing the software you're going, boy, I sure wish I had another sensor, it would be so much easier. You can then tell that to the hardware group and negotiate and get the people working with the hardware to come up with things. So that's one thing I'd look at the prototyping is how can you get the pieces together as soon as possible. The longer you go without assembling things, the harder it's going to be. You're going to have all kinds of assumptions that you're making, and you want to flesh out those assumptions right away so that you don't go down a dead end, or even worse, have to rework and throw away things, and you spend a lot of time doing it. And yeah, I would say things like making it functional first. Certainly, you want to focus on that versus making it pretty. And invariably in a team, you're going to end up having things like this case here. Gee, I have a really great design. We ought to do this design. We ought to do this. It's going to be really cool. It's going to solve the problem. Well, on paper, you can make anything work on paper. So it's sort of like show it in some kind of prototype or some subset of what you're talking about, and have a real working example. And if still there's someone who says, "Oh, I can do it better and better," and solve this problem, well, you have a working prototype that solves that problem. So it wins. And I got that from the Internet Engineering Task Force. They're the group that actually keeps the whole internet running. They came up with the standards, or that is, they adopted the standards that are accepted across the internet. They will not accept paper designs. They will not accept good intentions of this is how we ought to code it. Here's the spec. Okay, let's all do it. Yay, team! No, they go. Okay, that's nice. Bring us the code. And we'll look at it, and we'll see how it fits in and integrates with the big picture. If that works, then it gets accepted and becomes a standard. And if it doesn't, well, their working stuff is always going to win. They actually had a story of a bunch of IBM people came into their meetings. Anyone can attend a task force meeting. They're open to anyone. And they accept ideas based on what you can do, not what you say you can do. And so a bunch of IBM guys showed up and says, "Oh, we got this really great idea. We want you guys to, accept our standard and so on." And that's nice. Sounds like a cool standard. Show us the code. Well, they couldn't. So they thought that by making it a standard, they could force the group to implement the code. And it doesn't work that way in that particular case. In the case of a company, it would. Say, okay, programmers, make this spec happen. And that's what they were used to. So it turns out when you're dealing with prototypes and the kind of work you guys are doing, I would say, yeah, you want to go with what works for making like the stable internet stuff. So that's prototyping. It's another thing is, go with cheap materials. There's no need to go with expensive stuff. And it turns out in the business world, you have to go with cheap stuff. I hear stories of hardware engineers, scrambling around trying to find parts and stuff. They don't get the nice flashy parts and stuff. Prototypes are ugly. They always are. Even in software, they're ugly.
That's what we did at the robotics club back in high school. We had to scramble around for sphere aluminum.
Yeah.
We had to make a really big robot about that big.
Uh-huh.
Yeah, you've heard of FLURPS Robotics?
Yeah.
Yeah, we did first.
Okay.
Robots are typically about this high.
Off the floor, you mean?
Off the floor.
Yeah, right.
So near the end, we're kind of scrambling around. We have a lot of crap aluminum. It's like, how do we change it into what we need?
Right.
Like, our budget's not that big, and the majority of our budget goes to traveling and expenses of like hotel rooms.
Right.
Stuff.
And actually, since you're dealing with a one-off thing, is aluminum the right material? I heard you guys were doing foam board for stuff, and that's actually a really strong material. As light as weight as aluminum, and just about as strong. It's probably a little less resistant to bending than aluminum, but more flexible in the bend mode. But as far as compression and stuff, so yeah, that kind of that's where you're constantly scavenging for parts. So that's the other thing is try to figure out how you can keep your expenses low for your prototypes, and that's part of your decision of what you're going to prototype. Often is, gee, what materials do we have? See, I didn't talk about software much. One area of software is the air handling. For those of you who are interested in that, object-oriented programming definitely is good. And one of the things I discovered early on with object-oriented programming is the objects were still not paying attention to what happens when things go wrong. And I had done an analysis years ago of some commercial software that I was helping to maintain, and it was several 100,000 lines of code. And it was considered a very good product. It was a library routine that was used by a lot of different applications. And as I was looking at it, I discovered it was actually fairly hard to understand and to modify. And yet it was still a very usable product. So I looked at it and analyzed it and discovered that a third of the code was doing the actual work of exactly what it was supposed to do. Another third of the code was sort of test code, debug statements, and other little options you would turn on to verify things are working. And another third was for what I would call error handling, of detecting problems and figuring how to recover and how to roll back and so on. And so I realized that a lot of these life cycles, they only pay attention to the forward functional flow. And most engineers do that too. They will, got it running, here it is. And as a release engineer at the end of the product phase, I'm going, okay, what if the internet's down? Well, that won't happen. Yeah, okay, so, it's just, there's so many things like that, oh, what if that vendor's site is down and this other one is up? Did you check before you committed yourself to modifying the database? And if they didn't, gee, now we got to either manually repair the database, or gee, maybe your code is smart enough to fix it up. Or maybe it should have been smarter and not touch the database until it was sure it had everything. So that's error handling. It's basically paying attention to what can go wrong and figuring out how to design it so that you can manage that. And one of the techniques I discovered, I wrote it up in a paper on error handling, of how to structure your code so that that error handling stuff doesn't get all interleaved with what the code is really supposed to do. It turns out, you sort of like open a file. Well, what if the file isn't there? Or what if there's no permissions? Now you got to have a little if statement after it to handle it, to throw an error and say, whoops, can't read the file. So now you've got all kinds of things. You've got the forward flow interleaved with the backward flow. And it's hard to understand, what is this code really supposed to do? Because as you're reading it, you see all these other exceptions. So the modern style is to do exception handling. You take the forward flow and you take all the ifs and you put them after. And in this, you put what's called a try. And basically, go ahead and execute all these things. If any one of those fail, drop to the catch block. And the catch area will then decide what to do. So what you've done is you've made it easier to read the code. You've got the functional part that you can read, and you've got the other part when things go wrong. And you can actually design for that. And the really nice thing about it is you can do this one a bit later if you want. You can write all of this functional code, then go back and start slapping try blocks around things and handling the problem cases. And the nice thing about that too is, what about problems you didn't know would occur? In the case of do this, then you got ifs after everything. What if you forgot an if after something that was called? Oops, that's a pretty major defect. Next thing you know, your program is crashing because it's now in a state it doesn't understand. It just blithely went ahead. Even though the internet's down, it pretended it was still there somehow. I don't know, who knows what it does, right? So the nice thing about exception handling is if something like that happens, it's going to be thrown to the catch area, and it can at least do something and let you know that, hey, something really bad's happening. I'm not going to continue, instead of trying to continue with garbage. So that's my error handling rant.
It's definitely changed. I took Java back in 2005.
Yeah.
I took Java back in 2005. And the way it was outlined is just a normal statement, and then if it didn't work, then you put the if and then statement inside that function. It wouldn't be outside of the function.
Right, and that's a good strategy. You're right.
That's
what
how
you
I
do.
used to do it. It used to be threat statement. If this happens, blah blah blah. Go to this. If else, break it or whatever.
Yep, and that's exactly the strategy that I talked about in my paper. Is you put all of those ifs and stuff inside the functions as close to where the problem is. Yeah. And then if there's a problem, that function just does a throw, showing, hey, sorry, you haven't satisfied all the constraints that are needed. I'm done.
Right.
And what's nice about the throw is it goes to the catch area instead of the calling routine having to figure out by, sometimes I've seen code where they don't actually even return an error code. You have to determine it by, oh, you returned a 0. That must mean you were lost. When you were supposed to return a non-zero. That's, yikes. That now you've done two things. You've taken real data and made it a control data at the same time, and that's pretty scary.